And here is our quick pick of the day, sketching logarithmic functions. We are about to sketch f of x equals log base 4 of x. What we're going to explore is how do you do it on Desmos, how do you do it on your calculator, and how do you do it by hand. And certainly once you have a picture of it, it's very easy to identify the domain and range. All right, so let's dive into Desmos. Okay. So now what we're going to do is I have my lovely little helper today, and we're going to have her hit Desmos, and hopefully that's operating. And then she's going to type in the function, but she's going to hit, she's going to hit the functions key, and then it says miscellaneous. Now that appears to be a little blurry. Let's see if we can get the autofocus. There we go. There we go. So now she's miscellaneous. Now we're going to go for log base A, that button. Good. And now your subscript, it's prompting you for your subscript, so she's going to hit, oh, that part's off. Yeah, we'll have to scoot that back. So she's going to hit log base 4. Yep, and then she's going to go inside the argument there, and of x. Good. Now it's produced the graph. Now on top of that, we're going to go to the wheel. Now she's going to hit wheel. Now she's going to hit table. Okay, and poof, it produced the table of values. You can't get any better than that. So now what I'm going to say is this. I'm going to let her hold that there a second. Now we have a visual. We have a visual of what? We know what this thing looks like. And on top of that, do me a favor. Hit that arrow key right there. That's even better. Look at that. We have oops, let me erase my other mark there, if it'll let me. Yep. Now we have an even better visual that this thing, what's that word? It begins with an A. You guys can all say it. There you go. It's asymptotic to the what axis? To the y-axis. So what's its domain? 0 to infinity. Domain means what's its range?
Negative infinity to infinity.
Yeah, negative infinity to infinity. Yeah. So what I'm getting at is that's a terrible sketch there that I did, but once you have a visual on it, you can spot the domain and range real easy, real easy. Now, you might say, yeah, well, how do I know when this goes on out? You know, how do I know that it keeps climbing? Well, the appeal of Desmos, there comes my finger, the appeal of Desmos is that you can scoot it, you know? You can scoot it to explore whether those values are climbing higher and higher and higher as x gets bigger and bigger and bigger. Now, what I'm going to do is hit pause, and we're going to explore the calculator. Okay. So now here's the kicker. We have the graph and calculator, but there's no button. We're trying to graph y equals log base 4 of x. And there's no button for log base 4. There is natural log, right? There's natural log. I'm trying to get it to do the autofocus, which it should. There's natural log, and then there's regular log, which is log base 10. So regular log, natural log, but, you know, where's log base 4? Well, there isn't. However, you can use the base change law. Now, I'm sure you'll all be comfortable with that by the time rolls around. But what the base change law says is that it's perfectly legal for me to rewrite log base 4 of x as, let me grab I want to make some space here if it'll let me. I don't know if it'll let me. It's perfectly legal for me to rewrite this as log of x divided by log of 4. So long story short, I have to use the base change law to re-express it to type it into the calculator. So what she's going to do is she's going to type in, let me erase my writing here now. She's going to type in log of x divided by log of 4. And that's a law that you are allowed to use. Yep. And I like that she's chunking off the numerator. So she's saying log of x divided by, you might have to do an insert another parenthesis in there, but that's all right. We can go back and fix it. Yeah, right in there. Let's hit second insert. Insert. Yeah, another paren. Yeah, and you can put another one right. Oops, we don't want that guy. And then we'll go back here. And then, bing. Now you got log x over log 4, and just hit zoom 6. Zoom, yep. And voila. Now you look at that and you say, well, that's not asymptotic to the y-axis, Oh, but it is. So know that know the graphing calculator can be misleading, and that the only way we can explore that is trace, and move in. Where's your blinky thing? Oh, did I miss him? There. The only way you can explore that is asymptotic is to move in and zoom in and hit enter. See, now you start to say, oh, well, it does look like it's plummeting. It does look like it's plummeting towards that y-axis. And in fact, it is. It's going to drop off real quick. And now let's go ahead and show them the second table feature. And you can always retrieve the table of values. And notice that the table of values, I did want to mention that. The table of values is cueing you for your what? For your domain. Yeah, it's saying, look, 0 and beyond, you're getting an error. But once you go above 0, you're safe. You know what I mean? So that's showing you that your domain is anything above 0, which is exactly what we said the domain was. So I'm going to hit pause. Okay, so final frontier. By hand. That's everybody's favorite, right? So the thing is, when you say f of x equals log base 4 of x, that really means y equals log base 4 of x. And we know that it's perfectly legal to exponentiate and rewrite this as an exponential equation. And what would that be? That would be 4 to the y equals x. Now, if you haven't gotten comfortable with that rule or that process yet, it'll come in time. But it's 4 to the y equals x. Now, how does that help you? Well, then once you express it as this, it's very easy to create a table. Good old-fashioned XY table. That'll always work. So let's see if it'll let me scooch this. So I'm going to scooch that up. All right. Now, good old-fashioned XY table. Here's my X's. Here's my Y's. Now, the thing is, up until this point in the course, we had X as our input and Y was our output. Now, all of a sudden, guess who's our input? Yeah, Y's are our input. And so if you kind of want to think of it like that, I'm going to pick some Y input, store it in, and get some output, X being the output. Meaning, take -1, zoop, store it right there. 4 to the -1 is really a fourth. If you don't want to do mental gymnastics, type it out on the calculator. 4 to the 0, anything to the 0th power is 1. It's okay. Don't worry, I won't harass you. Anything to the 0th power is 1. Put 1 in. 4 to the 1st power is 4. Anything to the 1st power is itself. Put 2 in. 4 squared is 16. And voila. You say, how is that voila? Well, good old-fashioned point plotting. The thing is, good old-fashioned point plotting will always work. It's old. It's ancient, right? So 1, 0, there's 1, 0, 4, 1, there, oops, let me erase that guy. I didn't mean 4, 0, I meant 4, 1. So 4, 1 is over here. When you're way out at 16, you're at 2. So when you're way out at 16, you're only up at 2. So that's the point 16, 2. So we get a general scope on that. Now, what about this 1/4 -1? How do you plot that point? Well, over a little bit and then down at -1. Oh, so we see it's plummeting in that direction. So now you're getting a rough sketch, but that rough sketch is giving you a feel for what? The domain being 0 to infinity and the range being -infinity to infinity. So what I'm saying is, if you have the by-hand skill coupled with the calculator, coupled with Desmos, you're infallible.